I gave you on the side that A has a length of 2, mark that. And B has a length of 8. And you were asked to find all the missing parts. Now, missing, or find, not going to be too hard here, guys. Angle A is missing. I need it. Angle B is missing. I need it. And looks like also side C, I guess, is missing. Now, of those missing parts, which one do you think would be easiest to find? C. I can use directly C squared is equal to A squared plus B squared, since this is a right triangle. You guys, C squared is equal to, in this case, 2 squared plus 8 squared.
Square root 68.
How much was it?
Square root 68.
Well, it's 4 plus 64, 68, right? And we're doing a square root, and you know that's not a perfect square root. What does square root 68 look like simplified, if it can be simplified? What is it?
12 and 4.
I'm thinking something else. Anyway, 68 simplified, it's not perfect. 2 root 17. That's square root 68 simplified. That's like 4 times 17, that's 68. And guys, that would represent this, which is a nice number. I'm not going to ask you to estimate it. And that's side C. Now, where's the issue? I've got 2 angles missing. So the side here, I need a clever student to tell me, how can I find this? Try to find A first.
Lower sign.
Oh, no, no, discuss law signs, that's coming up. No, based on what you see right there in front of you, those nice little definitions from high school. How can I find, let's say, A, angle A, or at least set it up, yes?
Opposite over adjacent.
Thank you, that which is tangent.
Yeah.
Take tangent, angle A, and yes it is, opposite over adjacent, which in this case is 2 over 8. Which would look better as 1/4. Now, someone tell me now, I don't have A yet, I've got tan A. They want A, what's the size of the angle A? What might you have to do from there to go further? To actually find the size of the angle. They want A itself. Is A 30 degrees? Is it 20 degrees? Is it 42 degrees? What is it? What would you have to do? Give me an idea. And I'll have to ask June to help me out on this one. But what's the technique? You'd have to have a calculator and then do what to find what we're looking for. What we have to use on the keyboard of that calculator. We're going to do inverse tan. Look at this. Of 1/4. That should be A. Got to do an inverse on it.
Arc.
Okay, or arc in. But if you're using a calculator, June, would you find degrees inverse tan 1/4 or 0.25 and see what size that angle is close to?
14.03.
0.03. Do that. And she says, Professor, this is right here. Done. Now, could you do this without a calculator? No. But since she has a calculator, she's going to help me out, then I'll tell you what I would have to show on your test. So you could do it without a calculator. Guys, the other angle's missing. That's, let me put right here, 14.03. Angle B is missing. Give me a good way to find angle B.
19 plus 1403.
You mean add these up?
Yes.
Oh, by the way, what should all 3 angles sum up to for a triangle always? 180. So you could add this plus 90 and then subtract from 180. Or, if you're clever, just subtract this one from 90, and would that give you the missing angle?
75.
Okay, let's do this. Let's show for all students though. Angle A plus angle B. I don't know what you guys think. Yes, for a triangle, they always add up to 180 degrees. No matter what the triangle looks like. A, June gave that to me as this. B, we were looking for B. and C was 90. We do it in degrees here, 180. And you see what's going on here. D is merely, as I heard, I think a student tell me earlier, just 90 subtract what? 1403? You solve for B here, set 180 subtract all that, guys.
104.
104, right, there you go. 180 subtract, June, tell me what 180 subtract 104.03 gives me.
75.
What does that angle be finally?
75.97.
Is it 75 something?
0.97.
Oh, you've already got it. Hang on. Did you say 175?
No, 75.97.
75.97?
Yes.
June, is that what we're supposed to have?
Is 180 minus,
Minus the sum of these two, 90 plus 14, he called that 104. 180 subtract 104.03. Yes. He says 75.97.
I can't really see that.
90 minus 14.03.
Well, we got 90 plus, I have to add these two up.
Oh,
Oh, okay, 14.
Then 180 subtract that sum. Is that true?
Uh,
He's telling me in his head real quickly, he says it's 75.97.
oh, got it.
I'll put it here right now.
Just got it in sections.
oh.
75.97.
Thank you. Gee, calculation. So this is 75.97. Nice. And now the triangle's finished. Get all the missing parts. You can't go wrong with these. I don't think you could go wrong. Those definitions right above that we're using. Okay? Now, Marina, let's flip that over and see what's on the other side. See if I'm ready for it. Oh, am I ever ready for it? Here it goes. Okay, part 2. Guys, here goes. Now we'll do a non-right triangle. Does not contain a right angle. And by the way, it's got to contain a right angle to use those previous high school definitions. A non-right, they call them oblique. I'm gonna have mine look like this. And I got a question to ask you guys about this. Then we'll move on. I'm gonna have mine look something like this. And we'll label it, call it angle A, angle B, angle C, lowercase letters, no problem. That. Now, here's where I want to go. I need to express the best I can the area of that triangle. Now, someone go back to the high school problem first for me. Now, suppose across the street, I'm sure across the street we're being asked to do this. We've already found the missing parts here. But suppose across the street, the teacher says, okay, that's beautiful, you get credit, you get credit, you get credit, looking beautiful. And then another question about this is, don't leave this question until you answer this. What is the area, let's say square units, for this triangle? Does anyone remember, if it's a right triangle, was there a standard formula to find the area?
A times B times 1/2.
Yeah, 1/2 base times,
And B.
yeah, I think of another word. Height. 1/2 base times height. I think most middle school kids would say it like that. 1/2 base times height is a standard area formula, not for a circle, for a triangle. Now, if I apply it here, I would have 1/2, my base is 8, base of the triangle. The height, we lucked out, what's the height? Is that 2? That's right here, that's the height. And it looks like it is 8 square units, whatever the units would be. That's its area. 2 let me choose an 8. That's right. Now, how about the area of this one? Now watch carefully. This will be beautiful. I need the area of this non-right triangle. Now, can I jump in and use 1/2 base times height? No, because I don't see a height.
You can move.
Thank you. First thing, if I ask for this, here we go. This is my standard. First thing students notice, if you don't have a height, let's put a height in. Okay, we'll do it like this. We'll drop a perpendicular from point C down to my base and have that to represent the height of that triangle. Let's use H for height. Now, at this point on this particular triangle, now be careful. The C, lowercase c, on the base, that represents the length of the base, all the way across. So can anyone tell me at this point, if I'm gonna use that standard high school area formula for a triangle, what would it look like expressed right now for this triangle?
1 half BC, H,
Okay, 1/2, got you, and two more.
BC.
Well, the base, what's the base? B represents base.
Okay, AB.
Is that C in my case?
Yes.
Is that what B means, base? I know the base was, 8. Is that true? Just so happens the way I labeled my triangle on this one is the base C, lowercase c, base of the triangle, down here. So that B base is C in my case, that's the base, and of course I got the height labeled in the red there. That's what it looks like for this triangle at this point, 1/2 CH, HC. Now, step 2, which they may not know in the middle school, is, let's look at this, looks like since I dropped that perpendicular, do I have two small right triangles?
Yes.
Solved here, or involved, not solved, created. Let's look at each one separately. We'll look at the one on the left over here. Can anyone express for me to make this all time for us? What's the sine of angle A? Here's angle A right here. Sine of angle A,
H divided.
hang on. In the triangle on the left here, knowing sine is opposite over hypotenuse.
H divided.
H over what, B?
B.
Everyone agree? Okay, I'm gonna express it like this for a reason. I'm going to call this B sine A equals H. That's reworded, a little cross multiplication. I need it in that form. Now let's jump over to the other triangle, this one, and express the sine of angle B for that one. And sine again is opposite over hypotenuse. Guys, if I'm over here, angle B stared up here, the opposite of the hypotenuse would look like what on this triangle on the right? Opposite of hypotenuse for the triangle here. Is that H over A? Is it H over A? I think A is the hypotenuse. Better expressed for the reason I want to use it as this. That's step 2. Step 3, look at this. I'm going back to step 1. You draw an arrow. I'm going back up there. I'm going to rewrite my area formula with the help of step 2. So the area of a triangle, that's what the A represents. The area can be represented as 1/2 C. Now look at this. What could I replace H by at the beginning of here, at this point, if I wish?
Angle sine.
Do we have a substitute for it? Is there a substitute for H? One substitute's right there. B sine A. I can put that in, I'll put it in red. And I got it expressed like that. Another student may say, wait, professor, if you go back to the step 1, the area formula, look at this. 1/2 C again. And H, could they have replaced H by, was there another substitute there they could have used for H? I used this one. Is there another one there? Is it what, A sine B? Could have been used. Put it right here. Now, we slow down a little bit. How does one find the area of a triangle? Any triangle, oblique, right, watch what happens here. Arena says take 1/2, that's 1/2, both my versions here, 1/2, the product of two sides, in my case, B and C, here we go, B and C, B was, where was it? B and C, these two sides. That's this. And then times sine of angle A. Notice where angle A is located in reference to the two sides, B and C. Where's angle A located? In reference to sides B and C. Where's angle A located? Is it between the two sides that I'm talking about here, B and C? Is that angle caught between? I think your textbook says it's included between those two sides. So take 1/2 the product of two sides times the sine of that angle that's included between. Another student say, well, professor, that works. Here's another version. 1/2 of AC, these two sides, times the sine of what angle is included between those two. B, take the sine of what? Angle B. You'll get the answer again. Is that true? Then we jump back to the high school problem and ask you this question before we get all this done. The high school problem, we used the standard high school 1/2 base times height. Didn't we? Now suppose you use one of those versions over there. I could have found this area by taking 1/2 of the product of two sides. You choose the two sides. It's up to you. I would choose these two. 2 and 8. Now since I've chosen these two, it's sine of, in that formula there, sine of the angle included between. What angle is included between the two that I chose to work with? Is that the 90-degree angle? It's caught between. So I'm taking the sine of 90. Guys, if I work this out, that area should be 2's cancel. That's 8 times sine of 90. I think from the unit circle, the sine of 90 is 1. Is it? And we end up with an area of 8, which I think from high school we ended up with, where is it? 8. Is that true? Now, Selena, we could have chosen, I didn't. We could have chosen to use, and I may ask June to confirm this for me. We could have chosen that crazy angle. Now see if I can end up with 8 again. Area this time, if I had chosen, so it's 1/2. This time, the two sides would be these two sides, which are 8 and what was C, guys? Look at that string, it's over down there. Okay, 8 and C, 2 radical 17. You talking about crazy? Times the sine of, let me make sure everything's right here. The angle caught between is also crazy, it's 14.03. June, I am working you today. Let me do a little canceling for you though. Just cancel those out. June, could you find what 8 times sine of 14.03 degrees is? And we're so hoping it's 8.
8 times, square root of 17 sine.
Yeah, it's just 8 times square root 17. I did a little canceling. A times sine of 14.03.
It says 7.99.
7, okay, get 7.99 in the calculator. We got 8, didn't we? Is that good? Because it all depends on what you want to choose. You can use this distance over here to find the area. Now, someone tell me, in this clever class, I'm going to invite some professors in here one of these days. Tell me that one version of here I did not write down, which should also work. I started out with 1/2 B times C. I did these two sides. And then I did A and C. I did these two sides. Can someone tell me the two sides I did not do, which should also work if I wish, and write it on the side here? Does anyone see the other one missing at this point? 1/2 what? There's 3 choices. I did 2 choices for you. There's one more choice that should work if you wanted to do it. It was the sides that I did not use myself. I used these. I use these, what's left? For another choice. You could have chosen these, A and B. If I did though, it would be sine of what angle is included or between those two sides if I chose it. See? And I would've gotten the same answer, just like June did this back in high school for me. Look how crazy that looks. That gives me 8 again. That would have been your choice here. Now I've got 3 choices here. All right, guys, so if I ask you to find the area of a triangle, you have a choice. Choose these sides and sine of A. Choose these sides, sine of B. Choose these sides, sine of C. So you've got 3 versions of the formula that work for all triangles, not just right triangles, all triangles. Now what I want to do is, though, in closing down today, and I think we'll be shocked. These are area formulas. I'm moving over and do this. Down here nicely. Here goes. I'm going to jot these down, like you see right now. 1/2 BC sine A equal to 1/2 CA sine B 1/2 AB sine C. That's what we have. That's what on the board there for you. I'm going to do something with them and give you another formula. Now, don't confuse. If I ask you to find the area, you got to use one of these. You can't change it. You got to use one of these versions if I ask you to find the area. I'm now going to use this to develop another formula. Guys, to clean this up, I'm going to multiply everything by 2. Get rid of the fraction. If I multiply everything by 2, those 2's will cancel and leave me something nice. That leaves the 2's gone. And see if you guys will agree. Just multiply everything by 2. And then, to get to this formula I'm after, one more little step. And I bet when I do this, student will recognize what it's going to be. I want you to go through and divide these remaining parts by this expression. And simplify each term. First term, I think the B's cancel, C's cancel. I'm left with sine A, capital A, angle A, over lowercase a. Hang on. Next, see the A's canceling, C's cancel. I'm left with sine B, angle B, over lowercase b. How cute. How things are matching up. And the last one, looks like the A's cancel, B's cancel. I'm left with sine C, angle C, over C. That's another formula, guys. This is not the area formula. I use the area formula to get to it. This gives me something else. Now, I've heard a student say, Professor, I've seen this, and they give a name to it. And I bet some other students have seen it also. What's that name?
Law of sine.
They call it law of sines. Law of sines. By the way, is that on that handout that I just gave you guys? I know you're getting a little tired here. We'll slow down here shortly. That's law of sines. And I showed you where it came from. Rather than just giving it to you, I showed you where it came from. Law of sines. Now, arena, as I'm getting close to here, closing down. More than likely, I probably gave you a triangle to solve, I hope, which might require the law of sines. Okay, hang on. 1 second here. Arena, Did I have the triangle drawn for you, or did I just give the information? Okay. Tell me what, and we close down today, what information did I give you?
Angle A equals 40
40?
degrees. Yeah.
Hang on.
B equals 60 degrees.
60?
Yeah.
Okay.
And A equals 4.
Lowercase a is 4.
Yeah.
And more than likely it says what? Solve the triangle?
Solve and find the area.
Oh, and the area. That'd be a good place for us to stop. So guys, is this a right triangle? She gave me 60 and 40, that much right there is 100.
C is eight.
So the remaining 8, exactly, the remaining 8 was 80, so it's not a right triangle. It's oblique. Make it look like it's not right. Gonna make it look like mine over there, go for it. And we will set this up. Josie, if I give you one of these on the test, final exam, which I will, I can't give you 40. You can't find 40 without a calculator. So if I give you one of these, you have to be creative. All my measurements will either have to be 30, 60, 45, something like that. So you can deal with it from the unit circle. I could not give you 40. But we're gonna do 40. Okay, guys, the way you wanna label this, if you wanna put angle A up here, it's up to you. You get to label it however. I'm gonna put angle A here, B here, C, lowercase letters, like that. It's up to you as to how you label it. She gave me 40 degrees here. I'll mark it. B was 60. And A has a length of 4 units. They said, professor, find the missing parts. And also find the area. Missing, guys, angle C is missing, which I think is going to be the easiest to find. Side B is missing. I'll try and put the approximate symbol there. You may have to approximate that one. And I think side C is missing. We agree? Are those the missing parts? Now, I heard students quickly tell me angle C, professor, must be how much? 80 degrees. That was easy. All 3 angles should sum up to 180. Now, does anyone see a way to find, I don't care which one you find first, B or C, using one of those trig functions from high school? Oh, not from high school. High school here, right triangle. To find one of the missing parts, and I would think maybe law of signs might use. Go for it.
It's sine B is sine 60 divided by B equals to sine A. So sine 40 divided by B.
Ooh, okay, law of signs, here we go. So you said sine of 60.
Yes.
Hang on now. And he wants to put that over what?
B.
B, look at that. Now tell me another match.
Equals to sine 40
Sine 40,
divided by 4.
look at that. He's making an application of, where am I? This. He's matching things up, they look like the law of signs. Now he's matched it up for me. Now, I'm gonna do a quick cross multiplication with what you gave me. And when I say quick cross multiplication, we need to multiply these two together. I think that's the fastest way to do this. And make this 4 sine 60. And in the other direction, B sine 40. Takes a little effort, but we can do it. By the way, the sine 60, we can find on our own.
B divided by
Wow, okay, sine 60 is what, radical 3 over 2? Okay, I can put that in there myself if you want to. I'll do it. Jeez. Now here, of course, got B, and I have no idea. I don't have any information about 40 myself. I could go ahead and cancel one in here and call that what, 2? 2 radical 3 equals this. Now, the best I could do here with you guys, if they want side B, solve for B, is to divide by both sides by what, sine of 40? 40. These cancel. June, I need you. 2 radical 3 divided by side of 40. See, what on earth is that close to for side B here?
Sine of what?
Yeah, sine of 40.
40. It's 5.39.
5.39, we'll take that by calculator. Now keep in mind, when I ask you one of these on the test, I gotta put angles you recognize. You don't recognize 40. Yeah, I give you something you recognize. Side C is the only side left. Can we use C squared is equal to A squared plus B squared to find the last side? No, because this is not a right triangle.
Yes, we can use the same.
Oh, you want law of signs again? Okay, here we go now, be careful. On the side here, right here. Now, he wants to go back, says, Professor, I'm gonna match up something else and show you law of signs again. What do you have in mind this time?
Sine, C,
Now, if you say sine C, hang on,
sine 80.
over, well, we found C to be what, 80?
Yes,
Yeah, what put 80 in there, sine 80,
divided by C
there you go, and,
equals to sine 40 divided
Yes.
by 4.
yes.
It's twice bigger.
That true, guys? That true? Will you match that up? And are there other ways to match this up? There are. Now, you know how math is. We do our work, we know what we're doing, get your paper back, you lost a few points. Here's where it could go wrong. It's not gonna go wrong in this one. If, for example, Arena, if back here, I saw 40 and 60, now it's having a bad day, and it's supposed to be 100, and 180, subtract that, leaves me 80 over here. And I was having a bad day, and I said 40 plus 60, I'm so tired, it's 90. Or it's, let's say 70, I was just tired. I put these two together, for some reason I said not 100, I said 70, which would now make this, what, 110? And I would use that 110, that's gonna throw everything off. Everything off. We gotta be careful there. That 80 has to be used. So I gotta be very careful with the arithmetic here. Now, by the way, guys, the law of signs looks nice here. Let me do a quick cross multiplication. C sine 40 is equal to 4 sine 80. And we want to divide this by sine 40. Go for it. And June, for the last time, I think. Okay, these cancel. Guys, are we left with this? First check and see if I'm left with this.
Sine 2.
Is it 4 sine 80 divided by sine 40? Is that true? Okay, she's going to do that for me and see what the approximate answer there is. Or side C.
It's 4 sine 80 divided by sine 40.
4 sine 80 divided by sine 40.
6.13.
6.13. That goes here. And you have the triangle page. Whew. With law of signs. Wow, what a workout. You said, Professor, are you kidding? Is that chapter 7 done? Are you kidding, Professor? Is that done? I thought I'd finish it up today, but what do you think is left? You guys who know a little bit about this. What do you think is left, which I can do easily before the exam takes place tomorrow? What do you think's left to really say it's God for chapter 7?
Cosine.
Law of cosines. There's also a law of cosines. That looks way different than law of sines. And it can be used in certain instances. And I have not shown you that yet. That's the only thing left in chapter 7. And I think also on the back of the handout, was there a theater problem, something like the circle with the shaded region? We'll look at that. Wow, have we been off to this? Oh, law of cosines is mentioned here, by the way. So I'll do that tomorrow. And also show you the shaded region part. And therefore I can start chapter 11. Guys, any questions? Now let's take a breath. Jeez, whoo, professor. Is this the way it's gonna be in grad school, or when I get out to university, is it gonna be that much? No, their classes are probably an hour. Their classes are at most an hour. If you have a lab, you may have a little more time. But this class is about an hour, you have an hour with the professor, that professor's gone, and then, you try to find the TAs. You get to the university, the TAs do all the work there, of course. And they pay them well, the TAs. Mr. Park, June, are you guys being paid well? I hope so. Yeah, they're being paid well. And who does all the grading of the papers at the university? Not me. I do all the grading here. My TAs grade the papers. And who returns the paper to you? You report to the TA. The TA gives your exam back to you. And where's the professor? I just lecture. I just do what I'm doing right now, and then I walk out the door. Goodbye. They create the test. They grade the test. And they tell me what to report for a grade. And where am I? I'm in my office having coffee. Yeah. Geez. Santa Monica's not like that. No, I do it all. Guys, good class though today, very good class. We'll finish this up tomorrow. Now, my concern is for Cleveland. I got a few minutes. You know, I want it all my time. This test tomorrow really, really worries me. I know I gave you the sample, and I want you to look at that sample and construct your test, definitely. You guys, be ready. My goodness, I'll be here at 11:30, and we'll get through as much as we can on the handout, or as many questions as you guys have at 11:30. And I think by the show of hands, we'll have a big turnout.